Hello, this is Swati Patil. Today we will see different allocation methods. Many files are stored on the same disk. The problem is how to allocate the space to this file so that the disk space is utilized effectively and files can be accessed quickly. So allocation methods means whenever a file is stored, how that file is stored in the memory in different way. So there are three major methods for allocating disk space. First is contiguous allocation, linked allocation and index allocation. The name itself shows you how the file is allocated. In contiguous allocation, the blocks allocated are in contiguous fashion. Contiguous allocation requires that each file first occupy a set of contiguous blocks on the disk. Contiguous allocation of file is defined by disk address and length in the first block that we see in the given example. For example, the file starts at location B and the file size is n. So to occupy the file of size n which is starting from location B, so how it will be stored? It will be stored from B block, then one by one it will be allocated in the consecutive locations. So very first block is B, then the file will be allocated to B plus 1, B plus 2, B plus 3 up to B plus n minus 1. So in this way your file is allocated in the continuous fashion. The directory entry for each file indicates the address of the file, address of the starting block and the length of allocated file. For example, here in this diagram you can see the various files are there. For example, there are the files count, f, tr, mail, list. These are the number of files and its allocation is shown. For example, count file is starting at location 0 and it ends at 1. So what is the directory entry for that count file? Count file it starts 0 and length 2. तो यहाँ पे count के सामने जो start है उसके नीचे 0 लिखा है और length 2 है because it occupies continuously 2 blocks. Similarly for f block, it is starting from 6 block. So f के आगे 6 लिखा है and it has again 2 block size or 2 length. So that is 2 given here. For tr file is starting from 14 block. तो उसकी वजह से tr के सामने 14 लिखा है और कंटिन्यूसली 3 ब्लॉक्स उसने ऑक्यूपाई किए हैं. दैट्स वाई द लेंथ इज़ 3. फॉर एग्जांपल मेल ये जो फाइल है ये 19 ब्लॉक से स्टार्ट हुई है और कंटिन्यूसली उसने कितने ब्लॉक्स ऑक्यूपाई किए हैं? 1 2 3 4 5 6. सो 6 ब्लॉक्स इट हैज़ ऑक्यूपाइड. सो मेल ये जो फाइल है उसकी डायरेक्टरी एंट्री किस तरीके से होगी? मेल फाइल के लिए स्टार्ट रहेगा 19 और लेंथ रहेगा 16. सो दिस इज़ हाउ ईच एंड एवरी फाइल इज indicated in the directory, so that whenever user want to access that particular file, it will be searched in the directory and from the starting location of the directory the number of consecutive blocks has been read. So in this way you can access the file in the particular directory. So that is about contiguous memory location. All the file has to be stored at the contiguous memory location. But contiguous memory allocation has some problems. Finding the space for new file, because as you require continuous space you have to first of all find out the space for new file. But how we know the size of the file in advance? So if we allocate too little space, then it may create a problem. If we allocate too large space, it may waste the memory. So these are some of the disadvantages of contiguous allocation. So to remove that, another strategy, that is linked allocation, is there. What exactly linked allocation is? Now in contiguous memory allocation the blocks are allocated continuously, but in linked allocation the blocks are randomly linked to each other. The directory contains the pointer to the first block and the last block. In contiguous memory location, directory contains the start block and the length. Here in linked allocation, directory contains the pointer to the first block and the last block. For example, in this figure, this zip is one of the file. zip नाम की एक फाइल है जो आपकी मेमोरी में यहाँ पे स्टोर है. Now this zip file, how it is stored, for example, it will start from 9th. So 9th block directly, that is the randomly 9 block gets selected, randomly 9 block gets selected. So 9 block is linked to 16 block, 16 block is linked to first block is linked to 6th block, sorry 10th block, 10th block is linked to 25th block. So in this way the linked allocation file is linked to each other, and its corresponding directory entry is starting block is 9 and end point is or end block is 25. So internally when it goes to 9, that block is linked to 16, so it will directly go to 16 block. 16 linked to first block, so it will go to first block. Then it will link to 10th block, so it will go to 10th block. And after 10th block, the last block is 25, so it will go to 25th block. And in this way your file can be read in linked allocation. In this case, in linked allocation, we simply create a new entry in the directory and the size of file need not be declared when the file is created. On the contrary, in contiguous memory allocation, we have seen that contiguous memory allocation, we have to find the space for the new file. In advance, we should know the size of the file, but in linked allocation, the size of the file need not be declared when the file is created. So this is linked allocation. It has some disadvantages. This particular strategy is effectively only for sequential access file. For example, to find ith block in a file, we must start at the beginning of that file and follow the pointers until we get the ith block. Another disadvantage is that if the pointers requires 4 bytes out of 512 bytes, then 0.70% of disk is used for maintaining that pointers, and our motive is to give space to the file and not for maintaining the pointers. So this is one of the disadvantage, that linked allocation requires more space to maintain the pointers rather than information. And the third is indexed allocation. Index allocation solves the problem of linked allocation. Means index allocation can support the direct access to the blocks. That means here links are not supported or links are not given. You can directly access that particular block. In index allocation, all the pointers bringing together into one location called index block. Whatever blocks are occupied by the file, that block's pointers are bring into one block that is called as index block, and each file has its own index block, which is an array of disk blocks address. Now we will see how the scenario of indexed allocation strategy. So here you can see the file is stored at different location randomly, and all the pointers of different blocks are collected together in 19 block. So in the directory, index block is given, that is 19, and this 19 block contains the information regarding all the blocks where file is stored. So here 19 has the pointers of 9, 16, 1, 10 and 25. -1, -1, -1 indicates the empty spaces or empty blocks. Why this is happening? Because we cannot say what is the size of index block. Index block is nothing but where all the pointers of the blocks are collected together. So here in our example, 19 is the index block because all the pointers of blocks are collected to 19, and 19 has the information of all the pointers. So in directory structure, index block is given so that when users want some information or user want to use that file, he has to go, or operating system go at 19 block, and in 19 block it will go to 9, 16, 1, 10, 25 blocks, wherever we have stored the information. The directory contains the address of index block. Here we have given the directory contains the address of index block, so that is in our case it is 19. Drawbacks are also here for index allocation method. Pointer overhead of index block is generally greater than the pointer overhead of linked allocation. With indexed allocation, an entire index block must be allocated. the pointer raises the question of how large the index block size be. Here for example, we cannot determine the size of index block, how many blocks it can occupy, whether it can occupy 5 blocks, 6 blocks, 7 blocks or and so on. So in this case 19 index block has been occupied. How many blocks? 1, 2, 3, 4, 5. These are the 5 blocks where your file is stored, and -1, -1, -1 3 times means how many, what is the size? 1, 2, 3, 4, 5 and 5 plus 3 8. So 8 blocks can be occupied in 19 block. But for index allocation, the entire index blocks must be allocated, and the pointer raises the question how large the index block be. So here the question arises, how many blocks we can occupy in the index block, what is the capacity of index block, that is the drawback here. So we have seen three methods for file allocation, for allocation in the memory: contiguous memory allocation, linked allocation and index allocation.